Thank you very much, and thank you for having me here. Yes, I will today talk about collaborations between the industry and academy in the area of advanced materials in the context of this, and how this can we'll see there can help us get innovations from academy to industry. And all of us are interested in the greater good, right? We're talking about contributing to the climate changes and reducing the climate changes. We're also talking about fighting the pandemic when we had the COVID-19. But also for a company like SAAB, it's also about keeping people and society safe, which turned very relevant with the 24th of February last year. And in addition to this, to the greater good, as I said, a company also have to work with the business. They have to have horizons of the growth of the company to be able to continue their business. That's how they survive, of course. And there are typically 3 horizons of the growth of a company, where one is the immediate future and extending the company's core business here and now and in a close by future. And then we have the second one is building the momentum and emerging new businesses. And then the third one, analyzing and understanding the disruptive trends that can create options for future business. And that's, of course, a very long-term goal for 5, 10, 15 years. But it's still very important, and the companies tend to give quite a lot of effort in the first and the second one, because that's much closer by. But it's still very important to focus on the third one, and that is where the collaboration comes in, where we can collaborate between industry and academy to get really this push towards new trends. So understanding this future together, especially in a triple helix perspective with the industry, academy, and also the government, through funding, but also through collaboration with institutes, for example. And we've touched this before today, and I would like to emphasize this 8 of innovation, where the company comes with the application, the problem, and the question, while the industry comes with the application, while the academy comes with the technique and the understanding of the basic research. And it's in the middle we should meet, right? Finding prototypes, understanding together the application and the applied research. Yeah. Good. Yes. So we should meet in the middle, and it's also very important to use this as an aid, to use it in an iterative way. Not saying that the companies should say that this is the application we want, and the academy should say that, yeah, this is the technique that we have. But we have to do it in iterative and to work together to find ways forward. It tends to be so that if you collaborate on industry with the academy, that the industry asks the academy, what can you give us? While academy says, what numbers do you need? And that is something we have to understand together and find the way forward. So I will give a short view into a collaboration that has been really fruitful and going smoothly. This project started as we wanted to investigate if it was possible to produce structural aerospace materials with high strength and also electrical conductivity, so producing multifunctional materials. And by doing that, we could reduce the weight of the aircraft, as we can reduce the need of, for example, lightning strike protections. Today we use copper meshes, which add quite a lot of weight. But by introducing it to the material itself, we can reduce the need of that. And we wanted to see if it could be graphene that could help us with that, as graphene is a material with very high electrical conductivity and also high strength. This collaboration took off in 2014 when Brazil decided to buy the Gripen E fighter from Sweden, SAAB. And as an outcome from that, a Brazilian funding agency, the SAAB, started, which funded a postdoc that went to Chalmers for a postdoc in the graphene area, working on dispersion of graphene in polymers. Danilo Karastan then went back to Brazil, starting a research group there. And in 2018, or actually the 2017 call, I think it was, through Vinnova, which was a collaboration between two strategic innovation programs, Graphene and Lighter. We were funded, SAAB, UFABC, and Chalmers again, but this time also with two Swedish SMEs, 2D Fab, producing graphene materials, and also Blackwing, a lightweight and aeronautical producer, small company producing small aircrafts in Sweden. And also another academic partner from Brazil, where the Chalmers professor has a professor share as well. So that went on, and in 2020, we applied again to SISP for a new postdoc who came to Linköping University this time, and worked more on thermoplastics this time. From the beginning, we worked with epoxy material. Thermoplastics is more the plastics that you know. Meanwhile, we also applied again for a new project to Graphene Vinnova to investigate how graphene could be used to enhance the properties of thermoplastics. I will come a bit into that as well. So this was SAAB, UFABC, Linköping University, Chalmers also, sorry for that, it was hidden behind this grayish area here, and 2D Fab again. And now we are at the stage where we are looking for even more funding. So it's more or less 10 years we have been working together in this collaboration. And I would also like to emphasize a 2D Tech, a competence center that is ongoing within Chalmers as well, a very long-term funding, also funded through Vinnova, focused on graphene and the application of graphene in electronics, for example, but also for multifunctional composites, where we are focusing. So we have had this long-term collaboration. We have had 3 postdocs, we have 1 licentiate, we have 1 partially financed PhD, an assistant professor, an adjunct lecturer, but also been working in this iterative way. We started with wanting to have a lightning strike protection, and then we did it iterative to find other ways of using graphene. So this is some pictures from the first project, where we looked at the electrical conductivity, where we found out that adding graphene could drastically enhance the conductivity. And we also saw that This one is without. This is a lightning strike test. This one is without graphene, and this one is with graphene, so we can drastically reduce the damage. However, we also saw that it was some difficulties with the aggregation and agglomeration of graphene. So we did some studies of how to make that more efficient, and also combined graphene with carbon nanotubes to get it more dissolved. Then we learned from the epoxy project that we had here to learn and understand how to use this to do the dispersion, and also wanted to see if it was possible to use it in another polymer. A 3D thermoplastic, possible to use for 3D printing, lightweight materials, and also recyclable. So that's where we were, looking at these types of materials. And then we are in the present state where we also still have some problems with the agglomeration. And we are looking into the possibility of using other ways to direct the conductivity. We look into possibilities to use something called interpenetrated networks, that we can use both epoxy and thermoplastics to mix them and get graphene together in the boundaries between the epoxy and the graphene. We also look at possibilities to use magnetic fields to direct it. So that's an example of how to collaborate and to get forward and iterate it forward. But I would like to emphasize the challenges also in collaborations. I think this is the first part that we talked about, that the companies has 3 horizons. But the company has to understand that we have a need for focusing in the long term. We have to focus on the long shots as well. To put effort there and also to collaborate there. And also, I think it's important that we speak the same language. I feel that sometimes when we're talking, the academic partners talk quite deep about technique. Sometimes we have to find a way to communicate so that technicians can talk to each other and understand each other. And of course, the funding. It's important with the long-term fundings and also the investment from industry on these long shots, as I said. And I would also like to emphasize the center community building, which gives the possibility to have long-term collaborations. So keys to fruitful collaborations from my point of view is funding, of course, but also the partnership to find ways to understand each other. And one way which I think is fruitful is the way of working with persons having one foot in academy and one foot in the industry, to understand both of the words. Words like industry PhD student or an adjunct lecturer. Then you can really get the full understanding of both of them. Though it's still important to have it, it's quite common that if you have industry PhD student that put more or less all the time on the research when you do that. I think it's still very important to stick to your home organization as well, so that you understand both words. And by that, I think you can actually reduce the so-called valley of death and to collaborate to find ways to get research into products more easily. Thank you.